Hi, it's Joe, ZL1PMY, 7700 No TX Part 2. First of all, apology to the old man. He saw the first section of this video and he rang me to say that this particular radio has never been used on digital modes, which is fine, as it's not the PA that's gone but one of the pre-drivers. You know, that's fully accept that, that's not a problem. Second, a question by email as to what drive level I was putting in here, and the answer to that is 0 dBm, as there is a 22 dB pi attenuator, pi pad here before it gets to the amplifier. It's Wednesday afternoon at 3:45 and the parcel arrived 10 minutes ago, so I've soldered the device in using solder paste, because these devices have a metal plate underneath, which is how they transfer the heat, in this case to the PCB, not to the metal deck, and so you need to make sure that's got a good surface of solder attached to the whole plate, and it's easier to use paste than wire solder. And also off camera, I've had the board off and renewed the heatsink compound on the 3 transistors that do use the heatsink to sink heat. It's in the title, as they say. So I'm going to set the camera up on the spectrum analyzer and just repeat the test you saw last regarding gain, and then once we know we've got gain at this stage, we can then start to put the radio back together. So I'll set that up and be back with you shortly. So it's the same test as we did on the other video. I'm going to probe the input of the first amplifier with a capacitive probe, and you can see that is neg 27 dBm. I'm now going to the output. You can get the capacitive probe to go where I want it to go. And that is neg 14.4 dBm, and that now goes to the second stage of amplification, the AC 14.46, and the output of the second stage, which is the new transistor, is plus 6 dBm. So the transistor we just fitted, neg 14 input and plus 6 output. So we're quite confident that that stage is now working, so we can start to put the board back into the radio to get it to the point where we can actually use the radio exciter and actually measure the power output from the PA unit, make sure the fans come on, all that sort of thing, and then finally bolt it all up. So it'll take me a while to set that up, so I'll be back with you shortly. So I got it all back together and setting the RF power minimum, pushing transmit, it's in FM mode. So on the test set we've got 4 watts, that's the minimum power coming out. So I'm going to set it for 50 watts on the meter, and the test set says 40.95. It's a 10 dB pad, remember, in my test set. Now I'm going to set it for 100 watts, and that's exactly 100.1, and again up to 150 watts, and that's 150, and then 200 is actually 190.7. So I'll just back that off. My test set here is ex-German, but you can see it's 250 watts, but I'm not sure of the duty cycle, so I can't transmit for too long in it. So the next thing we're going to do is called a two-tone test. So we add two tones into the mic and look at the wave shape. So I've got to set that up. I need to dig another piece of test gear out. The two tones, you set them individually so that they give the same amount of modulation, and then you pick two tones that are not harmonically related, and you should get a pattern on the oscilloscope that is purely a sinusoidal envelope with no distortion showing, and then you know that everything you've done is correct. So when I've set that up, I'll come back to you. Okay, so we're set up for the two-tone test. The test set here has two audio generators on it. So we've set one at 1200 Hz, 1.2 kilohertz, and the other one at 1700 Hz or 1.7 kilohertz. They both have 5 millivolts output, and if I turn that one off, so we're turning off the 1.7. Sorry, let's turn it off. Try again. And we key the radio. I've got my monitor receiver running. What you see on the scope is a straightforward carrier, and we check that the level that's being produced for that tone is the same as it is for this tone. We'll turn that one off. I'll go back and turn that one on. So this is the higher tone, and you can see the level is the same. So we now do the test with two tones. What you should get is an envelope with a sinusoidal output, and there you see it. Sorry, I just leaned on the tuning knob. So if you look at the edge of the envelope going up, down and down, that's a perfect sinusoid where distortion would show up as being very peaky or very flat. And that test sorry, that test is at 100 watts. So I'm now going up to 200 watts. Just drop the sensitivity a bit. 200 watts, and then that's maximum power. Okay, and both fans are running. So bar a few little checks around the radio, we're going to call that done.